Okay.
All right. Welcome back, everybody. How did this problem go for you? Bless you.
That's you.
Oh,
Salud.
sorry. I'm so sorry.
It's okay. You can sneeze. It's normal. It is a-okay to sneeze away your fears. All right. What do we got? Let's see. Still waiting on a couple more votes.
I don't see a poll.
Interesting. I have no idea why that would be. Okay. Well, we'll see if you see the next one. Anyway, sharing the results. Hopefully everybody can see these. Looks like we're in the worlds of 4, and then a little bit of a mix. All right, so let's talk about this problem, because I do see some 2s and 3s. What do we find tough about this one? What was tough? Anybody?
Well, for me, I think in the beginning I was like overthinking it more so than anything, and then we started going down the right path and just kind of like refactoring it and making it better and better.
Nice. Cool. Okay. Anybody else have any other thoughts on this one?
Yeah, like our group, I think we were like having a little trouble like figuring out like what we were going to set our count to and then how we were going to use the count in our if statement. But I think actually she just messaged me and said that she fixed something and it started working. So
Oh, awesome.
yeah, so we just had to like switch some things around, but we actually use count as an object. So I don't know, Sam, if you want to share your screen. But yeah, we use count as an object, and then we loop through the string, and then we did if not count at string at I, then you would set your count string at I equal to 1, else return false. And then at
Okay.
the end, just overall returning true. But we were kind of hung up on that count as an object. I don't think we were really like understanding how to implement it in our if statement.
Okay. I gotcha. Cool. So yeah, what were some of the other approaches people tried? So you had a count object. That's really cool, Shia. Any other?
We basically did the same thing. We just did the frequency map, except all I did was if the conditional was the actual key in the object. So if it was at all true, then that means we've seen it already. So function's over.
Nice. Cool. Anyone else? Anything else?
So we end up using a set.
Cool.
So the set turned things up an extra notch for sure.
Nice. Okay. Yeah. Set. So a set is probably the best data structure I think that you could use for this problem. And the reason for that is there's nothing wrong if you did an object, but since we only care about if the elements are unique, we never need to do a count beyond 1. It's either there or not there. So it's more of like just like if it exists versus whether or not we actually need to know how many we have to go. So for this one, we could do something like, okay, const is unique. And it could just take in, we said it took in a string, right? And there's different ways. So we could just create our set. So we could say, hey, let set equal new set. And then we can iterate through that string. So for let character of string. And so if our set has this character, we can just go ahead and return false right there. So hey, if set.has character, we can just go ahead and return false. Otherwise, we can go ahead and add it. Set.add character. That's how the set API is, by the way, has add. And if we make it all the way through, it's safe to assume that we can go ahead and return true because we must have had uniques. So let's go ahead and try this. Console.log is unique. And we will say hello. And we'll run it and we get our true. And then we'll give it with a double L, how it's correctly spelled, and we should get false. So this is one way, right? You could get really fancy with it, and we could just have const is unique, and it would just take in a string, and this could just return new set at string dot size, because it's going to tell us the length, and if that's equal to our string dot length, we know it's true as well. So this would also work for your code.
Wait, what just happened just now?
What do you mean?
The whole thing. What if you said if it's equal to the string dot length?
Right, because a set has a size property to it, and so we could put every character of the string into a new set, and then we could just make sure that its size is the same as the string's length, because set is only going to have unique elements. If we had two L's in our hello here, we would end up with a set that was just HELO, which would not be the same length as our string.
Okay, yeah, I do remember you saying something. Yeah, the sets have to have a unique. Yeah. Okay.
They're just like objects, except for they don't have that key value.
Okay.
Yeah, I am playing golf a little bit. I like the other answer more. I like this answer more because I don't actually have to go through the whole string necessarily. Well, this one guarantees I'm going through the whole string. So let's talk about this extra question is, what if you cannot use an additional data structure? How could we do this then?
By iterating, but you're saying if we can't use like the set or like object to keep track of it?
Yep.
So I think that's the way that I wanted to do it in the beginning, just by creating two loops.
Mm-hmm.
And so we have the first loop, and then the second loop is going to compare everything from the first loop to, that way.
Awesome. Right. So you're talking nested loops, correct?
Nested loops, yes, nested loops. That is.
Yeah. So if we didn't want to have any additional space, if that was for some reason the requirement, right, we could just do a simple double for loop where I is 0, I is less than string length, I plus plus. And inside we could also loop again through our j, right, which is going to be I plus 1, because we don't want them to ever point to the exact same thing. String dot length, j plus plus. And then we could just do a simple, hey, if string at I is ever equal to string at j, then we could also just return false. Because there's no situation where our I and j would ever match unless they were the same. So here we could return true. Let's just check our work. What's the time complexity of this one though?
Quadratic.
Quadratic, yeah. And what's the space complexity?
Constant. Linear.
Exactly. I heard somebody whisper linear for some reason. No, this is always going to remain constant because no matter how big our string is, we don't have to have any extra space to look at it. However, in our really chosen answer here, what's our time complexity for this?
Linear.
That's right. How come?
Because we have to go. Well, yeah, we have to go through the string and see each character at least one time.
Right. So as our string gets larger and larger, we still have to keep going for longer and longer.
Yeah.
Exactly. So this is linear. And what's the space complexity for this?
Linear.
Correct. Space complexity is also linear because our set will, even though it's always just one set, what that set's going to contain is going to grow in relation to the size of our string. Awesome. All right, let's hit another one.
I actually have a question.
Yes. Awesome.
So, because it's the same, that was my solution, but Brandon asked me, and I didn't know the answer. What would happen if the non-unique characters were like further apart?
Why would that matter?
How isn't it only comparing isn't it just using two counters to compare the characters together? So is there
talking about this one?
Nah, the one below.
Oh, this one.
Yeah.
Oh, okay. So the way this one traverses here, let me stop the screen share for a second. I think it will make a lot more sense in just a second. I'm also going to stop the virtual background so I can use a whiteboard. Gotcha. I didn't understand your question at first. So when we have nested for loops like that, the reason it's quadratic is because we're checking every comparison. So let's say I have a 1, 2, 3. And we have, well, let me go even larger to make it a little bit more. 4, 5, right? So I've got this array and I have a pointer at 1. So this is my I and this is my J. This is nested. So the I loop doesn't get to continue until the J loop is done. So J goes here, J goes here, J goes here, and only then I gets to move here. And then J goes here, J goes here, right? And that's just going to keep going. I and J. So we get this like quadratic. Does that make sense? So it doesn't matter how far apart they are.
Yeah, I looked away for a second and it cut out. So I didn't realize that you nested them. I thought you just used two counters.
Oh, yeah, I got it.
But now that I know they're nested, that makes sense. Never mind.
Cool, no problem. Okay, this next problem is going to be really off. This next problem is off the chain, as they say. AKA, you're going to love it. Did you say who's they? So many people. Okay. This one, I want you to find the smallest missing element of a sorted array. So example input is like, let's say we have an array that is 0, 1, 2, 6, 9, right? This would return a 3 because it's missing a 3. Let's say, and this would return a 0 because it's missing a 0. And if I had 3, 4 here, this would return, oh, and let's also throw in a 0. This would return a 5. Okay, so find the smallest missing element in a sorted array. And I will share that in the chat. And we will have what, you're saying 5 minutes, John?
5? No, that's not fair. That's not fair. You won.
I think you're underestimating the difficulty of this question. I wouldn't give it at first take the brute force or obvious solution, but then think about how this could be improved. Okay? Breakout rooms, I'm going to give you all 10 minutes. Sorry, John. All right. And we will open rooms. Deja, Sin, and Ujwaka Basi. It says you're still here. Do you know where you're supposed to be?
Oh, remember, I had to leave for a little bit.
Oh, yeah.
Yeah, me too. I had to go downstairs.
Wait, do you guys want to be assigned back into rooms?
It doesn't matter,
Yeah.
to be honest.
Yeah, I was with John and Danny.
You're with
okay,
John
yeah.
and Danny. Oh, you're room 5, Sin. Okay. Deja, do you know where you were?
No,
Who were you with?
I wasn't here when.
Oh, you were
they got
gone
us on
completely.
Yeah.
Oh, okay. And where were you, D?
I wasn't put into a room yet. Like, I literally left, like, right before.
Oh, okay. Gotcha. Hey.
We needed like 2 minutes.
Yeah, like maybe like 4.
Like we
30
just
minutes?
needed to. We just were about to run the code, and then from there we got to find out if we got to debug or if it was flawless victory.
All right. How much time do we need? 1 is 0, 5 is 5 minutes.
Yeah, Jay, it works.
Oh, we let. Never mind. No minutes.
I don't know what y'all talking about. 5 minutes.
Okay, I am getting a nice split between 3 and 4. 3 and 5. Sorry. So I'm gonna give us 4 more minutes. Okay.
That's funny.
All right.
All right. Let's do it. Options 4 minutes. All right. See you soon.
Corey, you
Yes.
didn't make it through the problem, but I'm thinking to do a binary search.
Ooh, I like that thinking.
Right? Okay.
Why? What would be the benefit of the binary search?
Because if we do a binary search, then we can see if the number exists in that array.
See if what number exists in the array.
If the smallest number that we're okay. so you want to see if the smallest number that's missing is in the array. And you want to do that by minusing the indexes, the index that you're looking at from the previous index to see if that distance is greater than 1. If it's greater than 1, then you know that there's a missing number. And then that's all I got.
Okay, interesting. How do we do on this one overall? Let's see. How did we do? So the people, I'm seeing some 1s and 2s. For them, were you able to get the brute force solution?
No brute. We went straight for the binary search, so we were like putting that together.
Okay. Okay, let me share these results. Oh, we are pretty split between 3 through 5. Couple 2s, couple 1s. Let's talk about it. So yeah, so did any team solve it with the brute force solution?
Is the brute force solution using a count?
What do you mean by using a count?
So, right, because you said a sorted array.
Yes.
So, like, and given the example that you made, we were talking from 0 all the way through. So we just used a variable to count from 0. And then we started a loop with a conditional that the count and whatever the element was should be equal to one another.
Okay.
And as soon as it deviates from that, just to return what our count is,
Awesome.
because that would be the missing number and obviously the smallest one. And then if it completes the loop, then the way that we wrote our loop, it would just have already incremented that number, because like the last number is 4. So if that's true, then we increment the count to 5. But then because we used a for of loop, the loop would stop anyway. So we just return what our count was, which should be 5, because it would have been our next number if the loop were to continue.
Interesting. Okay. Yeah. That one is brute force. What's the time complexity of that?
That would be linear, because at the very least, you have to check every element in a worst case or normal scenario.
Cool. Yeah.
Best case is n log n.
N log n. Yeah. So yeah, let's talk about it, right? Like, so in this problem, this is kind of a cool problem, right? And sometimes you see problems might feel sometimes deceptively easy, right? Somebody could give you this problem. You could write find smallest, right? And we could take in the array, and then you could just do some kind of for loop, right? So for let I is 0, while I is less, and we could say less than or equal to or something, array.length, so that we're always going to go at least one past I plus plus, right? We could just iterate and then say like, hey, if I does not equal our array at I, then we can go ahead and return I, right? I think that's going to work. So let's just give it a shot just to make sure. I haven't actually written this ahead of time, but okay, so let's give these some numbers. Okay, R1. So we should get 305, right? And we get 305, right? So this, you could just write this, right? You could be in an interview, they could ask you, and you could just bang this out in a couple minutes, whatever it takes. And it's like, yeah, so that works. And this is cool, right? This is a pretty good solution. I'm using I to my advantage, because we see like I is all, since these numbers have to go along with I, as soon as they're no longer the same, we can return I. And this would work, this works for empty arrays too, because an empty array would have a length of 0. So since we're going to equal to 0, we're always going to eventually get an undefined, where our I will not, and our I won't equal undefined. So we'll always, that's why we can always do this. But, right, there's a better way. This is linear time. So if the array is 1,000,000 length, and the one I'm looking for is the number just after that, right? This is going to take 1,000,000 iterations. So that brings us to the next one, which is we could talk about. She mentioned it. Danny mentioned it. You guys were talking about binary search, right? So the hint for this problem is that they said sorted array. The moment you hear sorted array, your first thought should be, can I use binary search? Sometimes the answer is no, or you won't need to. But in this case, we definitely can. So let's go ahead and try again. So this time we'll find our smallest. We have our array. And we can go ahead and create some left side and our right side, left being at the beginning, right being at the end, and then we'll start narrowing it down dependent on how things go. So we'll say let left, we'll set that equal to 0, let right. This will be array.length -1. And then we can just go ahead and run this while loop. So while our left is less than or equal to right, we can go ahead and find our mid. So the first thing we'll do is find our mid index, say math.floor. By the way, there's a fancier way to write this, which it doesn't matter. We can do left plus right and say divided by 2. Right, so this will give us our mid index. And then what we care about is if the array at that mid index is equal to the mid index, right? That's kind of the fun thing there. So it's like, hey, if my array at mid index, if this does equal, let's say, my mid index, what do we want to do? What side would we want to move?
To the right?
Move what? Like move what to the right?
We want to look to the right.
Move our mid index to the right, you're saying. So on the next iteration, we'd want our mid index to be greater, is what you're saying, right?
Yeah.
Okay, so what would we have to adjust in order to make it so our mid index will get that value on the next iteration? Somebody is loud. Who is that? Let me mute them.
Reassign the right.
We would have to say that the mid index, we would have to reassign the mid index to left now.
So the mid index gets created with every iteration. So we don't want to reassign our mid index.
Okay, so we would want to, okay, so if something was left.
Yeah, so there's two variables.
Left would have to be iterated. I would have to be incremented, I mean.
Yeah, so if we're here and we're in the middle, we know that there's all of these can't be less than, because this is the same. So we want to look at this half. So what do we have to update?
So left is now mid index.
Exactly. So left has to get incremented or updated to mid index. And we could say +1 because we don't need to check that one again. Else, we can go ahead and what do we need to change in the event that it is already off? So that's like in this scenario, we have a 6. That's not right. Which way? So we now have to look at this half. So what do we update for this half?
The right pointer.
Exactly. Right. This time we're going to update our right. So be our mid index -1. And eventually we'll break out of this while loop and we can just go ahead and return left. And in doing so, when we run our code, we get our 305. And so what's the runtime of this?
Linear?
No.
No, this one was linear.
That's a log n log n.
N log n would be slower than this.
Log n.
This is log n. Nice.
Log n.
Right. Well, let's go back to the time complexity graphs. Gotta know this like the backhand, the order of these. Just keep thinking. This is a good one. Okay. What was that thing that Jenny told me to do?
Open a new tab. Open image in new tab. It's in the middle.
Got it. Thank you. Jenny's so good at that. Okay, right. We have constant. It's the fastest. Then we have log n. It's very low on there because log n is considered very fast, but it is slower than constant. Then we have our n. Then we have our n log n. This is our sort world, right? Then we have our n squared. Then we have our 2 to the n and our n factorial. And this is how they are, right? Anything in the dark green is excellent. Green is good. Yellow is fair. I don't see any fairs. Oh, that's more like down here. Bad is orange and red is horrible. And you can see this is some of the time complexities of different operations for things. Okay, like to find, if we wanted to access a specific element in a queue, it takes n, right? But in a specific array, it takes 1. And then there's lots of other cheat sheets here. That one. These are the time complexities of different types of sorts, right? See, merge sort is very good. N log n, n log n, n log n, no matter what the case is. Well, quick sort is best and average is n log n, but its worst is still n squared. And times bubble sort, best case is n, but average and worst are n squared. And we also, I guess we did insertion sort, which is the same as bubble sort. Space complexity is sometimes a thing, right? Bubble sort doesn't require extra space or anything, while our merge sort does. And our quick sort requires less space. But okay, so remember these, they help, right? Print them out, stick them on a shirt of the one you love, so every time you look at that person, you can remember it. All right, any questions on the find the smallest problem?
Yeah, quick question. So at the end you're returning left.
I
So
am.
I don't, I'm trying to, yeah, I don't understand that.
Let's see what happens if we return right. We get everything is off a little. So, yeah, that's a good question. With these, I usually futz around with the right combination. Sometimes it's less than or equal to, sometimes it's just less than, sometimes it's +1, sometimes it's not, sometimes it's -1, sometimes it's not. Sometimes it's left, sometimes it's right. Those are like all the little variables. We'd have to really walk it through. I guess because in the event that our right one was off but was the smallest, we would update our right, we would update our left to it, but this would be -1. I think there's some scenarios where we land on it, like we land on one that's not equal to it, and we're updating this, but that was actually the smallest number. Well, that's never the case with left. Does that make sense? Like
No.
if we land on 2 and this is not right, we want to start looking over here. But if we land on 1 here, like, okay, or if we landed on 1, let's say, our mid index, and we don't know where our left is, like this, there's a chance that there could be something off somewhere else because this one's already off. While if we land on one that's on, it's never off. So we it's safe to go with the one after that one that's on at a minimum.
Okay.
Because you see when it breaks here, these are what they're at. And so our right one is just 1 off each time from our left. You compare those. Just check both of them, walk it through. There's not like a great rule of thumb that I have for that.
Okay.
It's a good question though. Okay. Let's do another one. I'm super excited about that. So with this one comes a little bit of a reminder lesson. So let's pretend I have a nested array. I think I already wrote a nested array at one point. Okay, yeah, I did. Cool. So let's pretend I have this nested array. And I make a duplicate of this, right? So let's say I say let dupe, and I do array dot slice at 0. We've done this before, right? Is my dupe equal to my array, or is it new? Console.log dupe equal to array. Will this return true or false?
It'll be false.
Getting a false. Yep. It is indeed false. Okay, hang on. We're gonna have to write in the chat. Okay. So now, so that's cool, right? This is its own array. This is how we've been caught to duplicate that or that, like that, right? We've learned that way too. Or we could have learned concat array, right? Okay, those all return new arrays. Okay. Now, what's going to happen if I look at this array and I go 0, 1, 2, and I say dupe at 2, and I say 0. So, and I say is equal to the string cat, because I love cats, right? And I console log dupe, we should see a cat in there, right? Because we've updated dupe, correct? Let me know if I'm doing something you think's crazy.
I think that's right, yeah.
Okay, yeah, right, we see a cat. Now, in the chat, go ahead and tell me, on the count of 5, yes, if we'll see cat, no, if we won't. Okay, will we see a cat when I log the original array? In 5, 4, 3, 2, 1. Throw in your votes. I'm getting a lot of no's. I'm getting a couple of yeses. This is great. Okay. Let's see here. Let's read these. David with a no, Doug no, Marvin no, Kong no, Henry, Maria no, Siham no. Danny says yes. Interesting, Danny. You're gonna have to defend yourself. Javon says no. Ashia says no. Jay Jones says yeah. Oh, you're gonna have to talk. Deja says no. Marvin says nah, son. Kong no. Kevin Wong nay. Sin no. Samantha no. Dragabasi no. Brandon no. Danny writes it again. Ashia says yes, yes. Marvin says nay, my lord. Yeah. Okay, these are the same people writing over and over again. Okay.
I take it back. I really meant no.
You really meant no.
Yeah, I was bugging out. I was tripping.
Okay, so then it's just Jay Jones. You said yes, and Ashia. What do you think, Jay Jones, John?
I had also switched my answer to no, but I was when I was thinking initially, what was I thinking initially?
I thought you changed the array. I thought you changed dupe to array, and then you were console logging array.
I'm console logging array, but I just updated dupe.
You updated.
Yeah. I thought you updated.
Oh, okay. So you guys are both no's now.
Yeah.
And Ashia, you're a no. Now you've taken it back.
I'm a no.
So we're 100% of the class says no. Oh man, Jeopardy. What is yes?
That's
what is why?
First of all, I knew it was yes. Y'all scared me.
Sorry,
yes.
Too late, Danny.
I knew it was yes.
You don't get to be wrong with everybody else. You had your moment.
Dang, Danny.
We had no Mavericks. Everybody bent to the will of the majority. Oh.
Once I saw the whole class go with no, I'm like, I had to make it right.
Oh yeah.
Honestly, I thought no. For real, I did think no.
I know. We know. You told us that. We know you're not lying. Okay. Let's talk about this. So the way these work this is a shallow copy. All of these work this way. So even when you do objects, if an object is nested inside of another object, that still works. Each array has its own unique ID, right? So we are making a copy of the first array. The other arrays are still going to be copied in with their unique ID. It doesn't make a copy of everything. It makes it just puts the same elements in a new array. But these elements are still arrays themselves. So that's the same thing for, like, if I have an let object and I have a person object key pointing to Corey, name pointing to Corey, and I make a copy of this, and I'm like, oh yeah, I'm gonna make let copy equal object, and then I'm gonna say, well, copy has a name. Copy's name is cat, and I say copy dot person dot name is equal to cat, and I console log our original object. Same thing, right? It doesn't make a copy of everything. It only makes what's called a shallow copy. Let's write that in our notes. Shallow copy. Now, this is something really important to remember, especially when dealing with data and like trying to create pure reducers and things like that. You constantly have to be like updating, unless you use the help of some libraries like Lodash or underscore, which makes what's called a deep dupe. Can anybody guess what I'm about to ask you to write? Your task over the next 12 minutes is to write a deep dupe function that returns a copy of an array and all nested arrays inside it. Okay?
And these nested arrays are supposed to have all their own new unique IDs.
Yes, so I want to be able to do something like this where I'm going to say, so we have our deep dupe, let's call it, takes in an array, right? I want to be able to say, let dupe equal, well, I want to just use all those lines from above. Let me just copy them, right? I want to be able to do dupe, but instead of it be my slice, I'm going to call deep dupe on my array. And when I console log my array, it's not going to change. It will look like this. Okay? Any questions? Okay, we're going to work on this for 12 minutes. All right? I know you can do it. And I'm super stoked about this, Rob. All right, options, 12 minutes. See you soon. did this go? Free launch. Let's do it. How did this go? How did we do on this one?
I think we need a few more minutes.
Yeah, we did. We needed a few.
Anything with the Basquiat.
Okay. Do we need more time? Okay, so this was
Yeah.
the poll for how we did. Pretty split. How much more time would we need? 1 is 0, 5 is 5. Some people got let's see. Okay, we only have 17 votes. Okay, well, I'll end poll.
I think everybody's Zoom crashed.
So it looks like of the people that voted, like half the people don't need more time. So I think we should just go over this. Just to be fair to applicants there. The other half, I hopefully got, some ideas, some good opportunities. All right, so let's talk about this one. What did we find? What was tough about this one? Is that? Okay. What do we think? What was tough?
For the way we did it, where we were going about doing it is that we had, we were going to do it recursively. Is it okay if I share my screen?
Yeah, sure.
So everybody else could see it and stuff. So the way we were going about it so far, we didn't complete it, but we had an output array we were going to utilize for each for a side effect, check to see whether or not the element was an array or not. And if that was true, we were going to update our output and then call deep dupe again, and then push array back into, put the array or the element as the argument so that I can go back into the loop. So we just sort of got, I guess, like we were just sort of figuring out what the next steps would be. So we got a bit, we just needed a bit more time, but it's okay.
Cool. Yeah, that looks good. That was definitely looks like it's in the right direction. Yeah. So
Cool.
Can you stop sharing your screen?
Yeah.
So what did this remind anybody of any problems we've seen?
Flatten.
Flatten. Yeah. Somebody said it. David's saying it in the chat, right? This is almost identical to yesterday's problem. So if you remembered that one or practiced it a few times today, you probably would have banged this one out pretty quick. So let's go ahead and try it. So we'll go here and let's start. We can even write it in the same style as yesterday, right? We could say let output there, and we can iterate through our array. I choose a for each because I just need the element. I can get the index too, but I know I'm not going to return out of this for each. And then we can also just go ahead and do a little check. So if array dot is array, pass in the element. So if this element is in fact an array, we need to output dot push, but we have to call our deep dupe again on that element. Else, we can just go ahead and push that element into output. And at the very end, we can go ahead and return our output. And if we do
Output
that,
is spelled wrong on line 223.
sorry?
Output is spelled wrong.
Oh, thank you.
So I did get it. Well, I should have just ran it.
So if we do that and we run it, we see that our array is unchanged. While we should also console log dupe just for fun. So we have both. So we are able to make a successful duplication, right? This could be shortened down where I'm checking what to push. I could do is array in here when I can make it a lot shorter. Did anybody think of an even cleaner way to write this? Do we have any array methods available to us that just return the element acted on as a callback as a new array?
Map.
Map, right? We could write this. So this is very similar, by the way, to how we wrote our flatten yesterday, our nice flatten right here. But we could have also just mapped, right? We could have also, let's rewrite it, or let's adapt this. We could just do return array.map. And otherwise, we can just go ahead and return deep2 or return our element. And in doing so, this will also work. Right? And this could also just be a nice ternary as well. Which I think this is still pretty readable. So this is probably how I would write this one. Like so. And we get our answer. Any questions on this? Right, so try to remember these because I can promise you that I will ask another one of these questions in the near future. Not the test, but in the near future, because these kinds of problems do show up in interviews. Let's ask just one more problem for tonight. And that is a nice problem from Cracking the Coding Interview, which AKA my Bible. And this is called, no, not the Torah. Just preemptively saying that from the chat. Okay. I want, given a linked list, implement an algorithm to find the kth to last element. So let's say we have a node. We'll make a constructor, and this will be taking some value. Oops. And let's just build this out really quick. This dot val is equal to val, and we'll have this dot next is equal to null, right? Let's go ahead and make a couple nodes. So let A is equal to new node at B, at A. And then let's just do a few things. And we'll say, sorry, B, C, D, E, F, and like let's just go ahead and chain these. So A dot next is equal to B, B dot next is C, C dot next will be our D, D dot next, whoops, D dot next will be our E, E dot next will be our F, and that's it, right? A, B, C, D, E. Okay, so this is kth to last, so it's going to be const kth to last. So if I were to say, I'm just going to pass in k as well as our head in the linked list. And so if I called kth to last, so let's just make a couple test cases for us. Kth to last, and I passed in our A and 0. This should return our F. Okay. If I were to pass it in with a 1, this should return our E, because this is the one before the last, and so on. So 2 would be our D. Okay, any questions on how that's working?
Wait, what's...
Yeah, can you Can you just explain that last part again?
This is my input and this is my output. So A with the second to last to the last would return the D. So if it's in this order, this we wouldn't want the very last. We wouldn't want the first from last. We would want the second from last. Let's say. So I would want a D back. Bottom and working are. So somebody's talking about. So Giovanni, this is not a tree. This is a linked list. So there is no like bottom or top. You're just starting from the head. If that makes sense. Okay, any questions? I will share this code in the Slack channel so you can have something to start from. But any questions besides that? All right. This is a cool problem. There's some cool solutions out there. Don't look at the solutions because we can struggle for 15 minutes. And that's okay. But just know that we will get there is a cool solution at the end of this. Essentially, think about how you can maybe do this in one iteration, so to speak. Okay, yeah. Doug, what do you mean by can we change the node?
Like add to it, like add a previous property.
Oh, you want to add a previous property? You can as one solution, but then continue to try to work on one where we can't. Okay. Good question. Yeah, try to do it without that, but if you can't think of something, that's a good starting point. All right, so let's give these 17 minutes. This is kind of an interesting problem. All right.
Minutos, 3 minutos. Por favor.
I think you thinking chess, bro.
Okay, maybe cuatro, and we can't even hear you, Corey. So we're just gonna assume that you're giving us 5.
How much more time do we need? Sorry, thank you for letting me know you couldn't hear me. Somebody said it. Thanks. How much more time do we? I know we need more time, realistically.
Is 5 mean 50 minutes?
What'd you say?
Is 5 mean 50 minutes?
No, 5 doesn't mean 50 minutes. But that's good. I'm glad you want to keep working on that. Okay. So I'm based off these results, I'm assuming that there is one group that I didn't share it. Well, it's okay. I know what they were. Sorry. There was one group that finished. Is that right?
No, we're just kind of like stuck and over it.
Oh, okay. So you guys need more time. I will bounce into your group then.
I think our group kind of got it.
Yeah.
Your group got it. Okay, I will bounce into your group as well. Okay, I will. Let's give another 5 minutes. That was what most of that poll said. So, okay, I'll bounce to those 2 rooms. All right. Let's go 5 minutes, and then we're gonna go over it. All right. So give me a poll. How did this go? How did this go? How did this problem go?
How many problems did we do today?
I don't know. 1, 2, 3, 4, I think.
I think we might be 4 for 4 tonight.
Oh, wow. Nice. Yeah, so this is 4 problems today, right? The test, the actual DSA test will be have 3 hours, and I think it's 9 problems. Some are not all coding, but some are. So like 7 of them are coding. So keep that in mind as you're practicing. You really want to get your speed up, right? Obviously, you didn't practice the same problem for the whole time because it was like come group work, and then I went over it and back and forth. But that's the kind of goal you should be thinking of. If you can do 10 problems in an hour or an hour and a half, you'll be ready to kill it. I will share the results of this poll. So we feel like we got 4s and 5s. This is great. Also, I think the exam will be very fair. If you've been studying the things we've been working on and whatnot and go over, you will definitely do well.
We've done a lot in the past 3 days.
That's right. But if you're paying attention, I've dropped massive hints. If you've been paying attention, you pretty much know the entire test right now. Because I have continuously said which problems will be on the test.
And what is the exact date for the exam again?
The exact date is on Wednesday the 13th. So 1 week from tomorrow.
Cool.
And we will be practicing DSA and just getting up our chops. But, you know, obviously DSA practice goes deeper than just the exam, right? So, because it's really what you need to get that job interview. You'll be building stuff like crazy on the job, but in order to get it, you got to solve the problems, right? So this problem, we had some kind of linked list, right, where it was A through F. These numbers represent different Ks and the node that we would get back if given those Ks, but we start with our head node. What went well? What didn't go well? What were some of our strategies for this problem? Let's chat.
I think Brandon should explain it was his idea and it was successful.
Okay. Brandon, are you open to that?
Yeah. So what I did was we decided to traverse through the linked list. We also decided to like save each value in an array. So we had a pointer pointing to the head, and then we said while pointer is not equal to null, we pushed the pointer value into our array, and then we updated the pointer to the next node, and then at the end we just returned our array at the index of our array length -1 and then -k.
Cool. Do you think somebody from your team could show us the code on?
I could show it.
Great. Just so you could walk everybody in the class through what you just said.
This wasn't here before.
Okay, I see it. Can you repeat a little bit like what you said again, just while highlighting things for people?
Okay. So we created this array to save our values into. We have a pointer which is equal to our head. And then we said while the pointer is not equal to null, since we're traversing through the linked list, we saved each value into our array. So we pushed it. And then we updated our pointer to the next node. And then at the end, we returned our output at the index of our length -1 and then -k.
Cool. That's awesome. Does anybody have any questions about this implementation? I I guess not. Did anybody else solve it a different way?
Yeah, we kind of did the same thing. But the only difference is that and to keep track of everything, we created an object, and then we created an account and the keys incremented by one with inside our while loop. So the keys pointed to the actual the node, and then at the end we returned we did the object.keys, which turned it into an array, and then we did the same exact thing, returned the object at the length minus k.
Okay. Cool. Any other ways that people solve this one? What about what's the time complexity of these last two approaches?
Linear?
Yeah, right. Those last two approaches have been linear because we've iterated through the whole array, the whole linked list, right? That's unavoidable for this problem. And you could say like, yeah, okay. And then what about space complexity? What's our space complexity for those problems?
Linear.
Right. Thank you, Danny. Right. Those are also space complexity of linear, because for every additional node in the linked list, we're having to store an extra space for that in our program. Okay. And so the goal for this was to do this in linear, right? For time complexity, at least. And so, right, if we wanted to work, so let's see it, like, let's think about, like, we could do 2n. Like, let's say I want constant space and O of n time. So time and space. Right, let's pretend these were the goals. Well, we could keep a count and just figure out how long this is, right? That could be one thing. We could have this count where we keep incrementing it. And so we get like 1, 2, 3, 4, 5, 6. And we see that, you know, our count is 6. And then we could iterate, we can minus, once we know the length, right, we can minus k. So we could say count minus k. And then we could iterate it again to whatever this gives us. Right? Does that make sense?
Yes.
So this would still be O of one space, and it would be n time. But the negative is that we might have to iterate, we're kind of iterating through it, the linked list at least, twice. So it's technically 2n, but that breaks down to n. So that's cool, but what if I said, I really just want to iterate through it one time? How can we do that, right? Well, there was a hint I gave, 2 days ago, I think, when we went over linked list. And I said, whenever you get a linked list problem, something you might want to think about is what? Who remembers?
What's the double pointer thing? Or
Oh, and Marvin remembered. Yeah, Marvin said 2 pointers,
the
right?
runner and the walker?
A runner and a walker or something, right? So what if I had started with a pointer here and another pointer here, and I'll call this fast. And what if I moved my fast pointer up to k, right? So what if I moved it, let's say k was 3 or 2, which is supposed to give us this, right? What if I went ahead and moved it to here? So this is our fast pointer, and I just moved it up to k. And then I moved them together, right? So then our fast pointer would get moved to D. Our slow pointer would be moved to B. Our fast pointer would go to E. Our slow pointer would go to C. Our fast pointer would go to F. Our slow pointer would go to D. our fast pointer can't walk anymore, and then we return where our slow pointer is. Let's code it out, and maybe it will make a little bit more sense. So the idea is we can offset it, one pointer by the other, and by doing so, we'll be able to get a nice answer. Hearing some weird noise. Where's that coming from? Okay, it's gone. Let's take a look. I'm just have to set up the chat so I can see it during this. And let's do it. So we've got our K to last. So the first thing I could do is do a iteration, right? So let's go ahead and make a fast variable. Say let fast. And I can make my fast have the value of head. Then I can go ahead and get my head, my fast variable, to be, give it its head start, so to speak. So we'll say for let I equals 0, while I is less than k. What is that? I plus plus. And then we can go ahead and update our fast. So fast is equal to fast dot next, right? So this is going to take the lead, so to speak. Afterwards, we can just create a second variable called slow, point that to the head, and then they can walk together. So we can say, hey, while there's a fast, we can just go ahead and say fast is equal to fast dot next, and slow is equal to slow dot next. And eventually fast will hit the end of the list, and our slow will be k elements behind. And therefore, we can just return our slow, or slow.val, depending on what the problem is asking. And let's try it. So we run it, and we see null, where we should have had f, and we had F where we should have E, and we have E where we should have had D. What can we see? What do we notice? What do we notice about our output compared to what our output's supposed to be?
It's in reverse.
Okay.
Wait, actually, no. F seems to be there twice, I believe, for the output.
Well, this one is null where it should be F. This is the next node here. I'll make it a little more clear. Dot val.
You probably do. Would you have to?
Oops. Oh well, this throws an error because I can't call val on null. What were you saying, Henry?
From the looks of it, it looks like you're moving the fast once, like to one spot instead of two, like you explained. So
well, I put my fast ahead by k positions.
Okay.
So that's not the issue. But what's the relationship we notice between
It's like one up.
Yeah, exactly. Right. We see it's a one-off. So where might I fix my code if we see that everything is off by just one?
Maybe I shouldn't start at 0.
Okay. So if I started, what?
You're fast?
All right. So let's say I started at 1. Is that going to help us? No.
You're fast on next?
On line 256.
This is a good line. This doesn't.
On line 260.
All right, so this is really good. Just so you guys know, I didn't write this bug on purpose because this is an important bug that people hit all the time. So if we know we're one off, where else might we look? Where are we dealing with numerical counts?
Inside of the stuff, right? Where we're implementing?
Change I to
somewhere in here, right? Is our for loop.
I'm
So what's an easy one-off check? What's something we could change? Like we tried I here. That didn't work because that actually decreases our I, our head start.
Can it be by the amount that we're incrementing?
So we definitely want to increment by 1 each time.
Is it the I is greater? It should be greater than
less than
equal
equal
to
to
K.
It's
Oh,
I
yeah,
is less
that
than or
is-
E. By adding that, you can fix your one-off property
Oh, because it includes. Okay.
up to K, right? And then we get F, E, and D, and it works.
So Corey, all you're doing with this is like you're creating sort of like this like steady gap by the whatever value K is, right? And
That's
pretty much once the
totally right.
fastest the end, you're pretty much looking backwards, just seeing wherever your slow is because it's going to be like sort of like equidistant based on whatever the K
Yeah,
is.
I'm giving our fast a K distance head start because we want to go K from the end. So whenever fast is finished, that slow should then also, because it's not really fast or slow. It's really like head start and not head start, right? So
Yeah.
they actually end up moving at the same speed, but once there's already a separation. Because
Okay.
if you and I ran at the same speed, right? And it was 100-yard, 100-meter dash. Right, this goes for everyone. So if we're all running the same speed, and you and I wanted to be at 10 yards behind you at the end, right? And then we're running 100 meters and we're running the same speed, you would just have to start 10 meters ahead of me. And then we could run together and we would stay like the same distance. And whenever you'd finish, I'd be 10 meters behind. So I would be at the 90th meter mark. And so this is imploring that exact same idea. If we want to be Kth from the end, one of them will have a Kth head start. Okay. It's a cool problem. This problem does show up sometimes. It isn't Cracking the Coding Interview, which is just such a good book. Love it. Oh my God. Gail. Hot. So much brains. So attractive. Anyway, that is all that I had planned today. I do want to give people a bit of time to go over the previous answers and continue to work on whatever they need to for the rest of the time. Okay, I'm happy to stick around for questions. And that's it.